Hey everyone, in this video we're going to crack another big Dilra theme. Routes, networks and travel puzzles, cities connected by roads, stations connected by tracks, people going from A to B under weird constraints. These are the sets where you see a diagram with cities or junctions, arrows or lines connecting them, and questions like how many ways, what is the shortest path, what is the minimum time cost. If you don't have a framework, the diagram feels scary. With a framework, it becomes very manageable. Let's build that framework. Step 1. Stop seeing a picture. Start seeing a graph. First mental shift. You're not looking at a pretty diagram. You're looking at a graph. Nodes is equal to points. Edges is equal to connections. Sometimes edges have weights. So whenever you see a messy map, tell yourself, okay, these are just nodes plus edges. Nothing magical. Once you see it as a graph, you can apply standard patterns. Step 2. 3 common types of network questions. Most CAD-style route graph puzzles fall into one of these types. Shortest path, minimum cost. What is the shortest distance from A to F? What is the minimum time required if he must pass through C? Number of paths ways. In how many ways can you go from A to D without visiting B twice? How many routes are possible if you must pass through C exactly once? Flow capacity constraints. Only 2 units can go through this pipe. At most 3 people can travel on this path. You must not cross the same bridge twice. We'll focus on a general approach that works across these. Step 3. Always redraw the network cleanly. The diagram in the question is often scattered. Your first job, redraw it neatly on your rough sheet. Tips. Keep important nodes like start and end at opposite sides of your page. Place intermediate nodes so that arrows, lines don't crisscross like a spider web. Mark weights clearly on edges. Example skeleton. A. 5. B vertical bar backslash 3 4 vertical bar backslash C. 2. D. 1. E. Even a rough but consistent redraw helps your brain think clearly. Step 4. For shortest path. Think layer by layer. When weights are small and the graph is not huge, you don't need full Dijkstra algorithm. You can do a layered shortest path. Start from source node. For each neighboring node, write the minimum distance you know so far from A, go node by node, updating distances if you find a shorter route. Mini example. Distances. 8b, 4, 8c, 2, bd, 5, cd, 3, ce, 6, dt. To find shortest distance AE step by step. Start. A is equal to 0. From A to B is equal to 4 to C is equal to 2. So currently A, 0, B, 4, C, 2, D, infinity, E, infinity. Next, take the node with smallest current distance. From C to D, 2 plus 3 equals 5. From C to E, 2 plus 6 equals 8 now. A, 0, C, 2, B, 4, D, 5, E. 8 next smallest unprocessed node. B is equal to 4. From B to D, 4 plus 5 equals 9. Next, D is equal to 5. From D to E, 5 plus 2 equals 7. Better than previous. E is equal to 8. Update. E is equal to 7. So the shortest AE is equal to 7. You don't have to use the word Dijkstra. But this is the idea. Update best known distance to each node. Step 5. For counting paths. Use systematic listing, not random guessing. If the puzzle asks, in how many ways can you go from A to D? And the structure is not too big, do this. Break it into segments. From each node, list all ways to move forward. Mini example. A connects to B and C, B connects to D only. C connects to D and E. E connects to D. We want paths from A to D. Paths from A, B, D, from A, C, D, from A, C, E, D, so 3 paths. Process. Start at A. For each neighbor, walk forward until you hit D, listing all unique paths. Make sure you don't create cycles if the puzzle says no node repeated. In more structured grids, you can even use combinatorics. Number of paths is equal to number of ways to arrange R and D steps. Example: need 3 rights and 2 downs, total 5 moves paths is equal to 5C3 is equal to 10. CAT sometimes hides these inside a story. Step 6 for constraints like must pass through X or avoid Y. Classic trick. If you must go from A to F and must pass through C, you can break it into paths from A to C, paths from C to F, multiply. Total is equal to times if the choices in the two segments are independent. Similarly, if you must avoid Y, simply ignore all routes that go into Y in your listing. Or, conceptually, remove that node and its connecting edges from your diagram. For shortest paths with must pass through X, find shortest AX and shortest XF separately. Add them. Step 7. Recognizing and avoiding overkill. Sometimes a network looks big, but most of it is irrelevant for a particular question. For example, a big map, but the question says, from warehouse W1 to shop S2, what is the minimum distance if you must go via hub H? Here, you only care about W1HS2. Ignore parts of the graph that are not connected to W1HS2 or clearly longer detours. Don't try to understand every path in the entire map if the question only uses a subgraph. Step 8. How to practice before CAT. In the remaining days, do 2 to 3 network route sets. For each, redraw the network cleanly. Identify if the question is shortest path, number of paths, or some must pass avoid constraint. Apply the appropriate method. Layered distance updates for shortest paths. Systematic path listing for number of ways questions. Breaking at compulsory nodes. Don't get scared by the drawing. Once you convert it into nodes and edges, it becomes just another structured puzzle. To summarize, see every map as a graph, nodes and edges, sometimes with weights. Redraw it neatly and use distance updates for shortest path, systematic listing or combinations for number of paths, breaking at compulsory nodes for must pass through constraints. Ignore irrelevant parts of the network and focus on the portions used in the question.